if you add up this plus the SCF, not SCF yet, only SC complex. CDC4 is the epox protein. If you add them, you see the cyclin E ubiquitination is increased. Compare if you add up a control that do not have the epox protein. Of course, you only have ATP plus these guys. You have ATP and E1, E2 plus this guy, but without the epox protein. Cyclin E ubiquitination was not seen. Okay. This is done again for adding up SCF, SC complex plus epox dramatically increase the cyclin E ubiquitination. This is what I call a dirty gel. Dr. Bashako told us, probably more than 40 years ago when he ran the gel. Everybody look at it, your gel, why your gel is so dirty? Okay? It's because of the smear of the ubiquitination. The ubiquitination of the cyclin E make it smear, and then you look at that, it's such a dirty gel. Okay? But the control here with E1, E2, but no SCF, nothing happened. Nothing happened for cyclin E. And the cyclin E CDK2 is responsible for cyclin E self-ubiquitination, because if you add it there, the ubiquitination event is dramatically increased, because the cyclin E has a phosphorylation residue need to be recognized by epox. So if you have the cyclin E CDK2, but if you have cyclin E, but you have a kinase dead CDK2, the ubiquitination process got compromised. This is you see the phosphorylation site of the EPW of the cyclin E will be recognized. Here, cyclin E and CDK2. Okay, this is CDK2 could cause the phosphorylation on the cell phosphorylation site called the 348, and then GSK3 beta. And we talk about this for cyclin D. These kinases also responsible for cyclin E phosphorylation on this particular residue. Once cyclin E got phosphorylation on these two residues, will be recognized by FBW7. FBW7 recognizes it using the SCF complex by associating with the ubiquitin conjugating enzyme E2, or add the ubiquitin onto the cyclin E through the lysine 48 branching. Okay, and then you see this whole complex will be formed. Cyclin E got ubiquitination, thereby getting degraded. So that's for cyclin E. So about P57 now. P57 is degraded through the SCF complex as well. And the epox protein responsible for P57 degradation is SKB2. Here, we do another experiment called cycloheximide experiment. Cycloheximide is a chemical compound that inhibits de novo protein synthesis, meaning that inhibiting the new protein synthesis. So the old protein is there, still there, but following the time course, the old protein may get degraded. If they are very stable, you following the time course, you see less degradation. But if they are fast turnover, following the time course, you see them degraded very quickly. So they treated these cell line, wild type mast cell with the SKB2 null cell. This is a knockout cell of the SKB2, meaning the cell without SKB2. If you do that cycloheximide to find out the turnover rate of P57, you see that following 1 hour, 2 hours, P57 is gone. That's turnover rate of the P57. But if you look at them, the PPD7 level in the SKB2 null cell, you see, compared with the wild type, the PPD7 protein seems to be very stable, indicating that without SKB2, PPD7 is very stable, because SKB2 cannot recognize PPD7. Without SKB2, PPD7 will not be recognized by SCF complex, thereby degrading PPD7 get compromised. This one for P27, a very similar observation, because we know SKB2 also responsible for P27 degradation as well. Okay? But here, just as a control, that SKB2 null cell, okay, have no impact on HSP90 degradation. Okay? The ubiquitination experiment here, in vitro ubiquitination experiment, was done as well with P57 with cyclin E CDK2, because P57 need to be phosphorated by cyclin E CDK2 in order to be recognized by FBW7 by SKB2 complex, and causing the ubiquitination. You can see here the PPD7 is in the reaction with the EK2 with the CKS1 with these FBOX protein. PPD3 got ubiquitinated. Okay, without the FBOX protein, of course, PPD7 will not be ubiquitinated. Without the cyclin E CDK2 there, PPD7 ubiquitination seems to be compromised. So these proteins, if you knowing that where's the phosphorylation site on PPD7 recognized by cyclin E CDK2, the scientists have done is actually this particular site turning 310A, if they change the thread into alanine, compromise the recognition by SKB2. As you can see here, the PPD7 ubiquitination got compromised. So this is the site that supposedly the CDK2 phosphorylation site and allow the SKB2 to recognize this and causing PPD7 ubiquitination and degradation. We talk about P27, P57. Now I want to introduce to you another important protein called P53. I have emphasized this so many times. P53 is the #1 tumor suppressor gene product. But somehow cancer will be able to come up with a strategy to cause the PPD3 degradation. Okay? How they do it? They have come up with the MDM2 as an E3 ligase, and also come up another E3 ligase called CUP1. Okay? CUP1 is a ring-containing ubiquitin ligase. Okay? As you can see here, this is the protein organization of the CUP1 protein. Okay? It containing a ring domain here, and then contain all the WD40 repeat. Okay? Ring domain is located at 130 and then 173 amino acid, roughly here. And the WD40 repeat at 1, 2, 3, 4, 5, 6. Remember that we talk about FBW7 has a very similar motif, WD40 repeat, to recognize cyclin E. CUP1 here using this WD40 repeat to recognize P53. Okay? Again, to prove that these two proteins associate, they use the IP Western, okay? Immunoprecipitation of P53, and then immunoblock with a mid-tech of CUP1, meaning that CUP1 and P53 interact with each other. If you look at the cell overexpressed with CUP1, okay, PPD3 is going down. Okay? If these CUP1 we delete the ring domain containing protein, PBD3 is not going down. PBD3 instead is quite stable. Okay. The PBD3, do the ubiquitination experiment. If you transfect the cell with PBD3 plus HA ubiquitin plus CUP1, okay? The cell, if you look at the immunoprecipitation of a ubiquitinate form of any protein, blocking with the anti-PBD3 antibody, you see the PBD3 ubiquitination. The PBD3 ubiquitination is shown here because the CUP1 presence. But if you transfect the cell with the CUP1 delta ring, meaning wipe out the ring domain, PBD3 ubiquitination disappears. No longer be able to get ubiquitinated. In vitro ubiquitination was done here again. You added E1, E2, but without E3 ligase. You have a ubiquitin there, you have PBD3 there. Nothing happened. But you add a CUP1 as an E3 ligase. Now everything show up. You see the dirty gel of the PBD3 ubiquitination, indicating that CUP1 is responsible for P53 ubiquitination. We talked about 14-3 sigma before. Just here give you a brief flavor that this particular protein also could enhance PBD3 stabilization. As you can see here, MDM2 is an E3 ligase for PBD3. You will actually cause PBD3 downregulation if the co-present with PBD3. But in the same situation, if you increase the amount of 14-3 sigma, sigma could rescue the PBD3 expression, meaning that 14-3 do something to block MDM2 mediated PBD3 degradation. And how they do it? It actually is blocking the MDM2 mediated PBD3 ubiquitination. So the here without 14-3 sigma, there's some kind of dirty gel here, dirty band of the PBD3, meaning the PBD3 is ubiquitinated. But if you increase the amount of 14-3 sigma, the dirty band reduce, indicating that 14-3 sigma block the MDM2 mediated PBD3 ubiquitination. PBD3 is such an important tumor suppressor gene. The cancer could come out with several important deregulation of E3 ligase of PBD3. This is another one, a PBD3 E3 ligase called PIIH2. Okay? Stand for P53 inducible ring-containing 2 protein. Okay? It was induced by PBD3 because based on the study here, that if you treat the cell with cisplatin, this is a DNA damaging agent. Usually they have to cause the PBD3 elevation. PBD3 got elevated because the DNA damage. Okay, you can see, treat your cell with the cisplatin, the PBD3s are up, and thereby causing some of the target gene being upregulated, including WAF1, which is P21, including MDM2, which is another PBD3 target as well, including PIRH2. You see that? And then this PIRH2 indeed mediate the PBD3 ubiquitination because if you could transfect them into the cell, PBD3 got ubiquitinated. You can see just PBD3 and ubiquitin alone. PBD3 ubiquitination band was not so obvious. With the presence of MDM2, the dirty gel show up. With the PIH2, the dirty gel show up again, indicating that these 2 E3 ligases was able to cause the PBD3 ubiquitination. Okay? This is what PIH2 looks like. Okay? They total about 261 amino acids. They have a ring domain. PBD3 has a cousin, right? P73. Again, this protein also got degraded by ubiquitination process. PBD3 you see here, P73 have an alpha, beta, gamma form, etc. Okay, very complicated. But this form, alpha form has a motif here called PY motif. Actually, this PY motif will be recognized by a WW domain containing protein. And the scientist has found out a protein called itch. Okay? They will be able to recognize the P73 alpha and encoding P73 alpha degradation. This is the itch protein organization. They have a WW motif and they have these HEC domain. The HEC domain stands for human papillomavirus E6 protein C-terminal homology. Okay? Remember, I tell you again, HEC domain, homology to E6 C-terminal, E6 AP terminal. That's HEC domain. This is another E3 ligase motif. And they will be able to recognize P73 to cause P73 degradation. This is the itch, okay? And the WW motif here, this is WW domain bind to the protein with a particular proline motif called PY motif, okay? They will recognize the protein with PY motif, and then they have HEC domain. The name HEC domain comes from homologous to the E6 ABC terminal. It's located in the C terminal A, and they will be able to participate in P73 degradation. Let's take a look. Each in there was P73, but not P53. So there's some substrate specificity there. Okay? Doing the in vitro binding assay only show that the GST WW, remember the WW domain, they will try to using that as a motif to recognize P73 alpha. So, and then find that P73 alpha indeed was interacting with the WW motif. The co-IP experiment shown here, there's each wild type and then each mutant, okay? And then wild type interact with P73 alpha nicely, okay? But not with the P53, okay? See here is the HA attack of P73 alpha, HA attack of P53. Only recognize the P73 alpha because this is about P73 band. The P53 band is not being recognized. Okay, P53 is supposed to be lower, the site, okay, and you don't see the P53 band got recognized. So it suggests that each only bind to P73 alpha and not P53. Each ubiquitinate P73 alpha but not P53 because no binding to P53. Of course, you expect they will not ubiquitinate P53. Again, show here they interact the ubiquitination assay with each with the ubiquitin P73 alpha got ubiquitinated. With each alone, without ubiquitin, there's no ubiquitination. With mutant, okay, this is a mutant to wipe out the each activity. This is the CA30A. This is basically wipe out the HEC domain's activity to ubiquitinate P73. There's no ubiquitination. You only ubiquitinate P73 alpha because each P73 alpha got ubiquitinated. If you look at the each, okay, let me see the P53, where is P53? Each plus P53, no ubiquitination. Very specific. Okay? We see our cell just like a little universe. so much we don't know. And these different E3 ligands that recognize different type of substrate. Each recognize P73 alpha, but not P53. 1433 sigma, even though irregular cell cycle, but itself also a substrate of the ubiquitination. Okay, the ubiquitination for the 1433 sigma is called EFP. Again, this is a ring domain containing protein. There's a ring here. Doing the co-IP experiment, knowing that these EFP using these residue here between 81 and 480, this is the whole EFP sequence domain. The middle part is using for interacting with 1433 sigma. Sigma was ubiquitinated by the EFP. Okay, as you can see, with the sigma, with the ubiquitin, with the E2 enzyme, with the E3 enzyme, sigma got ubiquitinated. But if you mutate that ring, remember that ring is very important to transfer the ubiquitin onto the substrate. Without ring, sigma is no longer being ubiquitinated. Okay. I think I'm going to stop here. Okay. Probably a lot to digest. I hope you will not be confused. I know many of you probably did not have the experience for doing the research yet, but I hope I was able to give you some example that how this research was done. Okay? And then being a scientist, this is definitely a route that you need to go through. You want to be a research scientist, be a cancer researcher, you need to learn all these biotechnology, biotech technique, research technique, to do the Western blot, to do tissue culture, to do real-time PCR, to do shRNA knockdown, to do siRNA, and to do the immunoprecipitation complex, to the Western blot. Okay? But once you're familiar with that technique, everything seems very simple. Okay? Just like you eat and drink. You know you need a chopstick, you need a spoon to get the rice onto your mouth. So it's very simple, very exactly like you could do in your daily life. And so I encourage you, for those of you who plan to go to graduate school, to get a master's degree, if you have a chance to go to a lab to learn those techniques. Dr. Ling Fan introduces some of the cell culture techniques to many of you. Keep that knowledge. If you have a chance, go to a lab, volunteer in a lab, say, I want to do some tissue culture work, okay, to sharpen your research technique. Okay? If a lab allows you to do some Western blot, go ahead to learn it. And these are all important too, because I'm sure for those of the master students who already get involved in research, you read literature. These kind of gel you cannot avoid, right? Almost every paper, every research paper show you all these technology there. Western blot, immunoblotting, immunofluorescence, mutation, shRNA, siRNA, you name it. Okay, so I hopefully this lecture give you some inspiration for those who want to get involved in research. This definitely a must-learn technique to understand. So I'll stop here. I'll be able to answer some of the questions you have. Right now is the time to ask questions. question?
Dear Professor, I have a question on the slide about you compare about the structure of SCF complex and IPC. The slide just right after we have a break. I saw some question mark beside the structure of IPC. So I wonder, is that the question? You mean that the full structure is not identified yet?
You have good eyes. I think that some of the slide I used was a pretty old version. Okay, so later on has been characterized. So the question mark, some of them should be disappeared already. Okay, so the APC2, APC11, and other APC complex subunit has been well characterized. Okay, so that should be identified now. The question mark of some of the old slide is no longer applicable.